Okay, so number 30 says find the inverse of the following functions from problems 11 through 18 and prove their inverses using composition. So number 30 is f of x, and f of x is the square root of 5 minus x. Okay, so if I'm going to find the inverse, then I'm going to switch x and y. I'm going to square both sides. Okay, so I'm left with x squared equals 5 minus y. Then I'm going to subtract the 5 over. So x squared minus 5 equals negative y. And then I'm going to divide by a negative, and when you divide by a negative, remember you're dividing both terms, so that would be negative x squared plus 5. I'm going to put the equal sign over here and put f inverse. But then we're going to remember that if you only start with a square root, a single square root, then your inverse cannot be an entire quadratic. Okay? So, just as a reminder, this was the function whose its domain was negative infinity up to 5, because it was negative and then x minus 5. So if I put the negative x plus 5, just rewriting this, right? And then factored out the negative. So just as a reminder, it was a square root, flipped over the y, and then shifted to the right 5. So this is the function that we're dealing with, right? So this is the positive, even though it's going left, it is the positive square root. But if you just remember as far as like the quadratic goes, when I think about my sketch, this, its inverse cannot be the entire negative square root of x, or negative x squared plus 5. The reflection of this piece right here is only the right-hand side of this quadratic. So you see how those two are reflections of each other across the diagonal? Almost, not quite the way I've drawn it, but anyway. Just as a reminder, we had the domain of this original one. We said the domain of f was negative infinity up to 5. But then looking at the range is 0 to infinity. Well, that is my domain of my inverse. 0 to infinity, which means we're only the right-hand side, and the range is negative infinity up to 5. But anyway, that tells me that this right here, if that's the range of my original, then it's the domain restriction of my final, so x is going to be greater than or equal to 0. But I could also just remember, as long as it's the positive square root, even if you flip it over the y, if you don't flip it over the x, a positive square root is the right-hand side, a negative square root is the left-hand side. And there we go. We are supposed to prove their inverses using composition, so I'm going to do f of f inverse. So I'm going to start with the outer function, which is the square root of 5 minus something. And inside there we put the inverse, negative x squared plus 5. So I'm going to distribute that minus sign. Negative times the negative is positive, and negative times the positive is negative. The 5's will then go away, and the square root of x squared is x. So we're good. Alright. So number 31, it says g of x. We're supposed to find the inverse of that one. Okay? So g of x equals x minus 3 over 2x plus 5. So we're going to switch x and y. X equals y minus 3 over 2y plus 5. We're going to multiply by 2y plus 5 on both sides. Not numerator and denominator, but both sides. The reason being so those will go away. Then we're going to distribute the x. So it'll be 2xy plus 5x equals y minus 3. We're trying to solve for y, so we're going to want to get all the y's on the same side. Separate my problems. Okay, so I'm going to move this y over here, 2xy minus y, and I'm going to subtract the 5x over here. And I like to put the linear term before the constant, so that's why I put negative 5x minus 3, but if you put negative 3x minus 5, it's perfectly fine. Then the idea is to factor out the y. So if you factor out a y, it's like dividing by y, right? So 2x, y divided by y is 2x, minus y divided by y is 1. Don't forget that there's a 1 there. And then final answer, we're going to divide by 2x minus 1, and you get that the inverse of g is negative 5x minus 3 over 2x minus 1. Okay. Now we're supposed to prove that their inverse is using composition. So I'm going to do g of g inverse. G of g inverse, so I'm going to start with this function, something minus 3 over 2 times something plus 5. And that something is g inverse, which is negative 5x minus 3 over 2x minus 1. Negative 5x minus 3 over 2x minus 1. Okay, we're going to, now remember, those of you that are cool with that, you can just multiply by the whole numerator and the whole denominator by the common denominator, 2x minus 1. Well, the denominator that we have, not the common denominator, but the denominator that we have. But otherwise, you can do this where you find the common denominator, or you make them have a common denominator anyway, in the numerator and denominator. And we get, in the numerator, so just remember, here's our fraction bar for the middle one, right? My numerator expression is going to be negative 5x minus 3. Then we distribute this negative 3. So minus 6x, and then plus 3. So when I distribute that over the common denominator, 2x minus 1. Then my denominator becomes, I'm going to distribute this 2. So negative 10x minus 6 plus 10x minus 5 over the common denominator in the denominator 2x minus 1. And then I'm going to simplify my numerator and denominator. So I get negative 11x, the 3's go away, over the common denominator 2x minus 1 over the 10x's go away, negative 6 minus 5 is negative 11 over 2x minus 1. We're going to multiply by the reciprocal. 2x minus 1 over negative 11. The 2x minus 1's go away, the negative 11's go away, and I'm left with x. Check they are inverses. Okay, so I need to see that process and be convinced that you were able to do the math, okay? Okay, I'm going to end that video right there for that one.